Hi everyone. In this video we're going to go over the section 2.1 homework, and I'm going to answer any questions that you may have. If there is a question that is not covered in this video and you would like it added, just send me an email and let me know and I'll add it to the list. An important note before we get started is that the specific values and vertices referenced in these problems may differ from the problems in your homework set. For some of the problems, they may be the exact same, and for some of them, they may have slightly different values. So that way, you can use this as sort of a template instead of just using it to copy down the exact answers. Here we're looking at number 8 from the homework. It says name two triangles that are congruent by angle side angle. The quality of this graphic is not great, so I apologize for that, but it says we have 3 triangles here. We need to figure out which 2 are congruent. All right, so I'm going to refer to them right now as the triangle on the left, the triangle in the middle, and the triangle on the right. All right, so let's take a look at the triangle on the left here. So we have 2 sides marked and 2 angles marked. Right, so we could do side, angle, side, or we could do angle, side, angle. Right, so this is definitely an option for angle, side, angle. Looking at the triangle in the middle, we have 1 side marked and 2 angles marked. So right off the bat, we know that the triangle on the left is not going to be congruent to the triangle in the middle. They have 2 different sides labeled. Right, so this one's got only 1 side labeled, this one's got 2 sides labeled. So we can automatically figure out that the left triangle is not congruent to the middle triangle. But this is a contender for, let's see, this would be angle, angle, side. So this would be angle, angle, side. So this is out of the running, right? Because we were supposed to have angle, side, angle. And this one we have angle, angle, side. So we'll eliminate that one. So we can assume then that the remaining 2 triangles are the ones that are congruent, but let's make sure. We've got 2 sides labeled here, just like in the triangle on the left. And we've got 2 angles labeled, just like the triangle on the left. So we know now that we are working with the triangle on the left and the triangle on the right. So we'll just get rid of that one in the middle. And now we need to name these triangles. You're given these 3 options. It says choose the correct answer below. Triangle NMP is congruent to triangle QRS. Second option is triangle QRS is congruent to triangle TUV. And then the last option is triangle MNP is congruent to triangle TUV. All right, so notice that 2 of the answer choices involve the middle triangle that we have now eliminated, QRS. So we can automatically eliminate those 2 answer choices. We know that our triangle does not involve QRS. We eliminated that middle triangle. So that leaves us with just this one answer choice. Triangle MNP is congruent to triangle TUV. All right, but let's make sure that this is correct. So I like to start off with the right angle. So P, so I'm looking at the triangle on the left. P is the right angle, and that one comes last. Let's make sure that the right angle for the triangle on the right comes last. V is the right angle for the triangle on the right, and it comes last. Right, M for the triangle on the left, that is the one that is marked as, has our congruent symbol labeled there. So that one comes first. Let's make sure that the one that's labeled over here comes first. So that's T, and that one does come first. So that one checks out. And those 2 triangles are congruent by angle side angle, and we have now named them. Right, next we're looking at a little proof. This one is somewhat similar to one that we did in class. It says, prove the following statement using the given pieces of information. All right, so you're given this figure on the right here. Looks like a big isosceles triangle. So a big isosceles triangle. It says prove the following statements using the given pieces of information. The angle PGJ is congruent to the angle SGJ. So PGJ, so that angle right there, is congruent to SGJ. All right, those are already labeled, so we don't need to do anything there. Then the next piece of given information is that the line segment GJ is perpendicular to the line segment PS. All right, so GJ, that's here, is congruent to PS. All right, so it forms that right angle there. All right, it also forms a right angle here, if you want to add that in. All right, and then we're supposed to be proving that the angle PJG is congruent, that the triangle PJG is congruent to the triangle SJG. All right, so that's basically saying that this, let me switch to the laser pointer, that this triangle on the top is congruent to this triangle on the bottom. Now, the triangle on the top, the little triangle on the top and the little triangle on the bottom, they share a common side, GJ. So that side is common to both. So if we were to separate those into two separate drawings, so again, if we were to do something like two little separate drawings for these triangles, this would be J for both. This one is G. That one would be S. This one would be P. This would be G. Okay. That G didn't finish up there. There we go. All right, so if we were to separate those into two different triangles, we would be able to mark those two sides as congruent. We also know that this angle here is the same. So now you can sort of figure out that it looks like we're dealing with an angle side angle problem here. Excuse me, I wrote the wrong thing. Angle side angle problem. All right, so that just kind of gives us an idea of the direction that we're headed. All right, so let's start filling in our two-column proof. Our statement on the left for line 1 says that the line segment GJ is perpendicular to the line segment PS. That was given to you. The next line says the angle GJP and the angle GJS are right angles. That's by the definition of perpendicular. So by definition, a perpendicular line is going to form a right angle. All right, the next line, line 3, says that the angle GJP is congruent to the angle GJS. This comes from section 2.1. We learned that this is by the right angle congruent theorem. The next line, and the right angle congruent theorem just says all right angles are equal or congruent. All right angles are congruent. All right, the next line says that the line segment GJ is congruent to the line segment GJ. That is just the reflexive property. All right, line 5 says that the angle PGJ is congruent to the angle SGJ. That was given to you. All right, so that was the first thing up here that was given to you. And then the last line, line 6, says that the triangle PJG is congruent to the triangle SJG. And again, we figured out at the beginning by separating this into two little triangles and looking at what we were given that this was an angle side angle problem. So angle side angle. So by the angle side angle postulate, those two triangles are congruent. All right, and then our very last problem. There are many ways to do this problem, so I'm going to show you one way. if you find another easier way to do it, then by all means, feel free to do it that way. All right, so the first thing that I noticed up here is that this pair here forms a linear pair, or these angles are supplementary. All right, so 132 and then this angle here form a linear pair, so that means they add to 180. All right, so I just did 180 minus 132 to figure out the value of that angle, so that is 48 degrees. All right, so then I just came down here and drew or copied down this triangle and started filling it in. All right, so to figure out M, I know that for this triangle on the left, that these three angles need to add to 180. All right, so I did 90 plus 48 plus M equals 180. 90 plus 48 is 138. So subtracting 138 from 180 gives you 42. All right, so that tells me the value of M. All right, so I'll go ahead and fill that in. All right, next I need to find the value of N. All right, so now I'm looking at the triangle on the right. Notice that these two sides are labeled as congruent. That tells us that this is an isosceles triangle. So I'm going to use the isosceles base angle theorem, which tells me that if I have these two congruent sides of a triangle, then the angles that are opposite from those line segments, or the angles that are opposite from those sides, are congruent. All right, so this angle here must also be in degrees. All right, so now just looking at the triangle on the right here, 132 plus n must equal 180. Right, so 132 plus 2n is 180. Subtract 132 gives you 48. Right, and then we have to divide by 2 to get n by itself. So n is 24. N is 24 degrees. All right, and then you could verify this if you wanted to, just by adding up those angles, making sure they add to 180. And then you could even take it a step further and look at the triangle as a whole. So looking at this big triangle here, making sure that this 90 plus n plus n, making sure that that added to 180. So if you wanted to check your answer on this problem, it is possible. All right, so let me know if there's any other questions you would like me to go over for this video, and I will be happy to add those on to the end and re-upload. But otherwise, I will see you guys in the next video.